Example number 4 says a force of magnitude 12 newtons is applied to an 8 kilogram block at a downward angle of 30 degrees. The coefficient of static friction between the block and the floor is 0.7, and the coefficient of kinetic friction is 0.4. Does the block begin to slide or does it remain stationary? So remember, for something like this, in order for the block to begin to slide, that force applied has to overcome the maximum force of static friction. So we need to find what the maximum force of static friction is. First and foremost, let's just draw our free body diagram. So first, I'm going to split up that applied force into x and y components. So we have the applied force downward, which we know is 12 newtons. And then also, it looks like they give us this angle right here, and that is our 30 degrees. So our force applied in the x direction is to the right, and then our force applied in the y direction is down. So doing our math, we get force applied in the x direction is equal to 12 times a cosine of 30 degrees. Which is 10.39. And then force applied in the y direction is 12 times the sine of 30 degrees, which of course is 6 newtons. So now that we know that, we can draw our new free body diagram. And we have the force applied in the x direction, force applied in the y direction. We know the force of gravity is down, the normal force is up, and then the force of friction is to the left because the applied force in the x direction is to the right. So, like I said, in order to know whether or not the block begins to slide, we have to find the maximum force of static friction first. So force of friction static max will be equal to mu static times the normal force. Now here we can see that the normal force is equal to the force of gravity plus the force applied in the y direction, because again, we know that this block is not accelerating in the vertical direction, which means that our forces are balanced. So normal force equals force of gravity plus force applied in the y direction. So we know also that the force of gravity is mass times acceleration of gravity. So plugging that in for our normal force, we get force static max is mu s times mass times acceleration of gravity plus force applied in the y direction. So plugging our numbers in, we get mu static was 0.7 times the quantity mass, which was 8, times the acceleration of gravity, 9.8 meters per second squared, plus the force applied in the y direction, which was 6 newtons. And so we get 8 times 9.8 plus 6 times 0.7. Force static max is equal to 59.08 newtons. So we have to overcome that force static maximum of 59.08 newtons in order to start moving. So since our applied force in the x direction is only 10.39, that block is not going to start moving. It's going to remain stationary.